And let's get started. So today we're going to be talking about the point extensions. So alarms, trends, and totalization are the three types of point extensions that we can have. And then we'll talk about the point extension manager and the point extension defaults. So if we go to our workbench, which again is running a station inside my PC, on my Windows PC on the platform, and this is the station that I've logged into. And if we go and look at some points that we've been using so far, so we'll go into our custom control folder, and that's the graphic that we had, and these are the points that we've created. And if we look underneath this zone temperature point, we've already got an out of range and a numeric interval, so an out of range alarm and a numeric interval trend already set up on this numeric point, the zone temperature. So if I look at those as a property sheet, we'll see the extensions are a child underneath the zone temperature. So we've got our out of range alarm extension, and it has the option to be inhibited, so you can have a connection that will inhibit the alarm and stop it from being raised. So an example would be if when the air handling unit is not running, then you would inhibit the alarms for the zone temperature, because you don't care what the zone temperature is doing when the unit's not running. Okay, so set the alarm inhibit to true and the alarm won't be raised. But then when you restore the alarm, you take away the inhibit, there's a timer that starts to delay the raising of alarms. So if you started the air handling unit, you might want to wait 15 minutes before you raise the alarm. Okay, so the inhibit time starts when the inhibit is turned off. Okay, then you've got our current alarm state. So right now this point is in alarm low limit, so it's got the low alarm condition being met. And if we look at the out for the point, the status is showing alarm because it's in low alarm. All right. You can have a delay for the alarm condition and a delay for the return to normal. So I could say that it needs to go into alarm and stay there for 30 seconds before it raises an alarm. And likewise, when I return to normal, I might delay 30 seconds before I return to normal. So that picks up the instance where the point is changing rapidly around the alarm limit, and you can delay the alarm actually occurring. There's also which alarms are we going to monitor. There's the to off normal and to fault. So there's two sets of alarms for an analog point. There's off normal and there's fault. So the fault condition in Facility Explorer is to detect when there is a fault with the input to the BMS. So if your temperature sensor goes open circuit or closed circuit, that would be considered a fault. Whereas your temperature going very high, so going to say 29 degrees, that would be considered off normal. Okay, so a fault is to pick up a problem with the input, whereas the off normal is to pick up a problem with the zone temperature in that particular space. All right. So in this case, we would say we don't want to worry about the default conditions. We'll just worry about off-normal reports. So we save that. The off-normal times, this is recording the last time it went to off-normal, the last time it was acknowledged, and how many times has it been in that off-normal condition. Okay, likewise for the to fault, it's never actually been in fault. Okay, and then how long has it been in the current state? So right now it's in low limit, and it's been there for 3 minutes and 58 seconds. Okay. Then the source name is, when we raise this alarm, what will we call, what will it be called? How will it appear? And at the moment, the source name is the parent dot display name. So because it's inside the percent signal character, it's displaying the parent dot display name, which means the parent of this object, which is the out of range alarm extension, and then the display name of the parent. So the parent will be ZN-T. So the alarm will be displayed as parent as ZN-T. Okay. Now, if we go and look down here, we can see that alarms will be sent to the critical alarm class. And as we discussed the other day, in our services alarm service, we have our critical alarms console that we created. If we look here, we've got an alarm which says ZN-T. So that was the alarm that results from this alarm extension. Okay, and the source name is the parent, which in this case, ZN-T. If I go back to my wire sheet, and find this ZN-T, there it is there. Okay, if I duplicate that, and it's now, and I call it, say, zone 1 E, or just call it zone 1 temperature. Okay, so there it is. If I use this to set the value of it, so, okay, so now we've got, it's running. So because I copied it, when I look inside, I'm now looking at zone 1 temperature. I've got the same out of range extension that's been created with the same parent.display name. And right now it's normal. And we'll expect it to go into high alarm at 25 or low alarm at 21.5. So we'll see what happens. So we just keep working through this and we'll see what happens when this one goes into alarm. We should see it show up as zone 1 temp instead of ZN-T. Okay, now what if we wanted to have, so zone 1 temperature is not very helpful. What if we wanted to have, call it the computer room zone 1 temperature? Okay, all right, so let's just leave that to next time it goes into alarm. No, it didn't go into alarm that time. So that's how the alarm will be displayed, or the source of the alarm. When it goes into fault, which we aren't using, so we're not using the fault condition. When it goes to normal, to off normal, we can say you can have a message. And inside this message, we could put in parent, parent display name, and we could also put in the value, which would be % parent dot out dot value. Let's save that. And then when it returns to normal, we could do that. Save that. So there are our text messages that we can attach to our alarm. We can provide a link to a graphic when the alarm occurs. So in here, I could go to my component chooser and choose my custom control and display the graphic for that custom control. If I wanted to play a sound, I could put a sound file in there. If I wanted to have an icon for this particular alarm, I could nominate an icon file in there. If I wanted to have a set of instructions I can create them in here. So I could add an instruction that says okay. Then we've got our two algorithms, our fault algorithm. Again, this is to detect when a sensor goes out of range. We're not going to use this fault algorithm, so we'll just leave it all as blank and we won't enable the limits. Then we've got the off normal algorithm. And for that, we've got a high limit of 25.0 and a low limit of 21.5, a dead band of 1 degree. We've got text associated with the high limit and text associated with the low limit. And we actually enable the low and the high. So if you just cared about high temperatures, you could not enable the low limit. Okay, but we want to do both. So we'll save that. So 21.5 and 25. So right now we're still normal and we're going up 6, 7, and we just dipped under that. So next time the temperature goes, let's change it to 24 and we'll see what we get. So save that to 24. Aha, so it's had alarm inhibit, so we're in that 15-minute window there. Okay, so what are we going to do about that? We'll have to we'll take that alarm inhibit out, save it. So next time it goes up above, still being inhibited. Yeah, I've got, what do I do? I will So I will get rid of this alarm extension. So first I will copy it and then I will delete it. Then I'll go here and I will paste it. So now it's back in here, but this time I don't have an inhibit timer in here. So I don't have that first 15 minutes of inhibit that I was running into before. So now, if we should be good to go. No, it doesn't like it. I think it's because this is the name of the alarm. So that alarm is in there already. So let's change the name to computer room 1 and save it. Let's see whether what that does for us. As our temperature goes above 24, which it didn't do. Let's make that 23.5 and save it. Didn't get there. All right, let's go back here and look at our wire sheet. This is our point, which has still got the alarm inhibit problem. So let's duplicate that, call it zone 2 temperature. Go. Okay. Let's come out of there into there. Go okay. Let's get rid of this altogether. And let's say we want to, let's just do it all from scratch so that we don't have anything hanging over us. So we'll get rid of this guy as well. Delete. Okay. So we've just got our standard temperature and the value is changing like that. There's no extensions. If we want to add an extension, we can go to our control palette, extensions, alarm. If we want to add an alarm extension, if we go to our alarm palette, extensions, out of range alarm extension. So we can drag that and drop it onto the temperature. Okay. We won't do anything with the inhibit. We'll take away the to fault option. It's parent display name, so it'll be zone to temperature. And we'll put a bit of text in front of that called computer room A. Save that. We'll come in here as our off normal algorithm, and right now we're getting about 23. So we'll make 23.5 our high limit. And our low limit can be 22, and our dead band can be 1. We'll save that. Save that. And we'll enable both of those. And we'll send the alarm to the critical alarm class. We'll save it all. So 23 and 22. So it's in high limit, high alarm, it's in alarm and it's unacknowledged. And now when we go back to our critical alarms console, this is the one we just created. Okay. And this is the one we were working with before. It's now 15 minutes has gone by, so it's no longer inhibited. If we double click on this, we'll see just that alarm. And we can acknowledge it. So it's still off normal at the moment. So we can acknowledge it. This is the zone, the ZNT alarm. It's currently normal. So when we acknowledge it, it's removed from the list. Okay, but while it's off normal, it stays in the list even though it's been acknowledged. You can right click on an alarm and look at the details. Okay. Okay. If we go back and look at our points, they're up there at 24. They're still in alarm. They're going down to 23. So they're not going down below. To go out of alarm, they have to go down to 22.5 degrees. So 1 degree below the high limit. Okay, so I might go to this one and change that to 24.5. So when we get down to 23.5, it returns back to normal. Okay, so it's no longer showing as alarm, but it's showing as unacknowledged alarm. If we go back to our alarm console for critical alarms, this one's returned to normal, and I can acknowledge it. This one, sorry, I acknowledge it, and it's gone. We go back to our wire sheet at 24.5. If we get there, which we won't do, so we okay. So that's our alarm extension, or out of range alarm extension, which we add to numeric points. Okay, so numeric writable or numeric, we can have an out of range extension. We go look at our custom control and look at our wire sheet. We've got some Boolean points here that are turning on and off. So an example is our cooling output here. All right. So if I wanted to put an alarm on this Boolean point, I would double click. At the moment, I don't have an alarm on there. So I get my alarm palette, and then I can go Boolean change of state alarm. Okay. So if I drag and drop that onto my Boolean point, this is my Boolean change of state alarm. Again, I got the alarm inhibit. I won't touch that because it makes it all too hard. Then again, I've got a fault condition or an off normal. I won't use the fault. And I've got my off normal algorithm here. And in here, I just nominate which of the two states, either on or off, is my alarm state. So in this case, I will say that on is the alarm state, and it'll be a critical alarm. And this time I will say the source name is %parent dot parent dot display name and backslash. So what I'm saying there, so parent display name backslash parent display name. So I'm going up to my first parent, which is cool, and my second parent, which is display, is custom control. So that first field is going to resolve to custom control. The second one, which is parent.display name, will resolve to cool, because that's the parent of this object, this Boolean change of state alarm extension. Okay, so I do all of that and go save. This is currently off. When it turns to on, I will expect to get a critical alarm raised. Okay. If I put in here my component chooser and find my custom control and go OK. And from here I look at my graphic. So I've now got a hyperlink, the custom control for this. Okay. Still off. So it's still in the normal state, which is this state here, normal. Okay, so it just turned on and went into alarm. Okay, and then it turned off, went back to normal. So if I look in my critical alarms, here's my custom control cool, custom control / cool. That's my alarm. Okay, if I click on it, custom control, that's that one there. It's got the hyperlink option here, or a hyperlink down the bottom. If I can click on it, click the hyperlink, and it goes to that hyperlink. So when an alarm comes up, you can go to a particular graphic. All right. I can return back to my alarm console. This is back to normal. Okay. And I can acknowledge it. It's returned to normal. It's going back in alarm, which I acknowledge. This one I can acknowledge. This one I can acknowledge. Okay, so they're all currently off normal. So in this alarm console here, on the top right-hand corner here, I've got the option to display additional information. Okay, so I can click on things like I can display the normal time. And next time we get an alarm, let's go back, see what our and acknowledge that. Now it's returned to normal, and we can see at what time that happened. Yeah, we can acknowledge it, acknowledge that one. Okay, so you can display these, any of these sources in this console. You can also add additional ones, things like the good. So instructions. Okay, so that's that check computer room instruction that we added to this guy. Okay, so that's now in this list that we can turn on and off. If we want to add anything extra to that list, we can go here and select. So all of this information here is, if we right click and view the alarm details, this is all of the information associated with that alarm, and anything here can be put into this console as a column, right? So things like source name, which is that one there, that column source, alarm value, and so on. Number of times it's in, so the count is part of that. Yeah. Okay. So that was our off normal alarm. All right. We go back to our wire sheet. So this is our cooling output here, and he's regularly turning on and off, and every time he turns on, just say we had a cool status indication, okay? So, and we had bit of kit control. We have a timer. So we come out of here into here. And then say 10 seconds after we turn on and 10 seconds after we turn off. We have status. So the unit turns on, then the status comes on. So this could be a fan, this could be a fan, and this could be the fan status. Okay, so when the air pressure switch closes, it would come on. So we've just got a delay in here just to simulate that when we turn this on, 10 seconds later we see this come on. We turn that off, 10 seconds later this goes off. Now, if we wanted to set up an alarm that says, I want to have an alarm when the status doesn't start or when the status doesn't stop. Okay, so for that, we go in here to our property sheet. We'll get rid of all of these. Delete. Delete. Now, if we go to our kit control, then alarm, nothing in there, so we'll go to our alarm palette, extensions, Boolean, And the alarm we want is command, Boolean command failure. Okay. So it's Boolean because we're going to put it onto a Boolean point. Okay. So we grab Boolean and we drop it onto there. Okay. When we look at our off normal algorithm, we've got feedback. Okay. Actually, we've done this the wrong way around. Let's go back. We'll set up the alarm on the command because it's the command failure that we want to pick up, not the status. So if we go here, sorry, we go to our output and we get rid of all of these. Get rid of all of these extensions. And now we'll go and drag command failure. Okay, so this is the command point. This is the point that comes on. And then 10 seconds later, we get the status come on. All right. So we add this. And in our off normal algorithm, we'll have a feedback value, which is the status coming back. All right. So if we go, this is our status here. We get the output, comes out of here and goes back to here as feedback. Okay, so I drop it onto there. And I don't get to make that connection. So instead I'll go to my this is where I am in my custom control. Got my cool output. And I've got, where is it? There's my cool status. And this is my cool output with my command failure extension. All right. So if I right click on here and go link mark, then I go to my cool status, right click, and I'm going to link to my command failure extension. So I'm going to come out of my status and into the feedback. Where is that? Not there. I have to go a bit deeper still. My off normal algorithm. Let's go there and go right click and mark. Then I can go here, link from, link to my off normal algorithm. I'm going to come out of here and connect to there. Okay. I'll set up the rest of it. Critical. That out. And we'll wait for this to come around again and start turning on. So when at the moment we've got a delay in there for 10 seconds each way. So 10 seconds for the status to come on, 10 seconds for the status to go off. So under normal operation, we would expect the status to appear within 10 seconds. So we come in here and we set our time delay to say 15 seconds. And our return to normal, we'll make that 15 seconds as well. Okay. So we would expect that when this comes on, we won't get an alarm. So our heating is coming on. But our next time that goes back up. While we're waiting for that to happen, is there any questions on any of this? There's nothing in the chat. Okay.
So all these alarm extensions, they don't consume any points as well, right, David?
What's that?
Alarm extensions don't consume any points.
That's right. They're not included in the point count. Yep.
Yeah, but if we do the alarm in the DDC and bring it in to FX, then it'll be a point. That's
right. So if you, in your field controller, if you had an alarm calculation that then turned on an output or turned on a network point that said alarm, and you mapped that back through the BACnet network or the Modbus network, then that would count as a point. Yeah.
In your experience,
Yeah.
Is it better to do the logic in the DDC or in the FX80?
In the
What's your-
FX80, yeah. So I would do the, so if it's, say, an analog point, then if you do the logic in the FX80 in the supervisor as an alarm extension, then you get to set those limits. It's easy to set the limits and change the limits. You've got all of the features of an analog alarm, okay? Whereas if you did it down in the DDC, you'd have to have the high limit and the low limit in the DDC. They would turn on an output. You would bring that output as a binary input, and it would either be alarm or normal. And you might bring in a second input. So you might have one input for high alarm and another input for low alarm, but they'd either be true or false. They wouldn't, you don't get any indication of what the temperature actually is. You just get the fact that it's in alarm or not in alarm. So yeah, I wouldn't put the alarms logic down in the field controller. The only time you might would be if you had to do something in the field, like turn a light on the switchboard or in the corridor or something like that, to indicate that you've got an alarm condition. But other than that, if the alarm is really just intended to be put in front of an operator in an alarm console or send us an email, then I would do it this way in the supervisor. Yeah.
Right. There's a question in the chat.
Yeah. Okay, so how many limits are, so everything takes up space in the controller, but generally the limit is the 200 points coming in from the field. Sorry, the 200 devices coming in from the field, and the points that go with them. So if you're, yeah, typically speaking, you could put alarm limits on every point, and that would be fine. You know, whether your operator really needs alarms on every point is another thing. So yeah, in practice, you won't run into any limits on alarm extensions. Okay, when we talk about trend extensions, there may be, that's another issue which we'll discuss. But for alarms, you wouldn't expect to have any problems with memory. Okay, so while we've been watching this cooling point is coming on, and then the alarm status is bringing up an alarm because we've got an alarm. We'll get rid of that one because it shouldn't be there. If we go back, as our temperature comes up, goes up and down, we see this goes off, the status goes off, and the temperature comes back up. Oh no, we've missed out. So we just missed that temperature comes up, Okay, so currently we've got the cooling coming on at 24 degrees. If we change that to 23, go okay. So now our cooling should come on. We're watching this temperature here. When it gets up to 23, we expect our output to come on. No, didn't get there. Let's change that. Set point to 22. So it's on. This is on. In 10 seconds time, this should be on. There it is. And we didn't get an alarm, okay? Now, if I override this to inactive, okay, so next time around, this comes on, this timer times out. And we've got an alarm raised because we didn't get the status come on when we were expecting it to come on. Okay. And if we look at our alarm extension here, it's going to be called parent display name, so it's going to be called cool. If we look at our console, we've got our alarm. Currently it's returned to normal. We acknowledge all of those alarms. Okay, so this is going into alarm each time because the status is failing to come on. Yeah. Now, if we take away that override that we've got in there, our status is now good, and we should be able to clear our alarm. by acknowledging so just to make that a little bit clearer. If I take control of this point and make it inactive, it turns off. Ten seconds later, this goes off. If I turn it on, 10 seconds later, this should come on. Yep. And I don't get any alarm. Okay. If I go to my status and I override it off, I should see an alarm in my console after 15 seconds. Oh, too slow. Sorry, critical alarms. Sorry, wrong console. There's my alarm, which I can acknowledge, but it's still off normal. Go back to here. So this turned on, but we didn't get status come back, so we got an alarm. All right. If we do get status, in 15 seconds time, that alarm should clear. Okay, so the alarm's cleared. Go back to our critical alarm console. There it is. It's normal. I can acknowledge it, and it's gone. While I'm here, I can acknowledge these other ones. Okay. Go back. So, action. It's currently on. Action, turn it off. 10 seconds later, this goes off. Everything is good. No alarm raised, no nothing. So what we did for all that was, in our output, we had our Boolean command failure alarm extension. And then on our input, which is our fan status or our cool status in this case, we take that value and we connect it to the feedback value on that command failure extension. Okay. So that's an alarm that failed. That's for units that failed to start or failed to stop. We can put that back to auto, and it should be all good. So that's alarms for numeric points and Boolean points. And then we've got enum writable or enum points. Okay, so just say we had okay, just say I had a point called off auto or off on auto. So here's my alarm writable point, enum point, and I will set up my states to be 0 is off, 1 is on, and 2 is auto, and I modify that, and 3 is removed. Okay, okay, save. Now I can action set the value to off. Okay, so now I've got a point where I can command it to be either off, on, or auto. Now, if I wanted to put an alarm on this point so that whenever it wasn't in auto, I would have an alarm. Okay, so for that, we go to our alarm palette and our alarm extensions, and this time we have to look at enum extensions. And if I go enum change of state alarm extension and drop it on there, there's the extension. It's got all the usual things. Again, we don't need the fault. In our, actually we do, we could use the fault this time. Let's say we save that. So we could say that when the only valid value is auto, okay, so any time that it's not in auto, it'll be in fault. Okay, let's make that a critical alarm. And then the alarm values, let's say that manual on is considered an alarm because it's now running in manual and we want to know about that. Okay, now we can save. So now let's go, and the point name is going to be parent display name. So it's going to be called off on auto. Let's go back. So currently the output is off. Which is considered a fault. And it should be in the critical alarms as a fault, which we can acknowledge. If we set the value back to auto, the fault clears. We go back to our critical alarms. There it is. We can acknowledge that, and it's taken out of the list. Set the value to off. So this time we'll set it to on, sorry. Set it to on. It's in fault and it's also in alarm. Okay. And if we go and look at our critical alarms, it's in fault. We acknowledge that. We go back. We now set it to off. It's still in fault because it's not in auto. We can acknowledge that. Go back. This time we return it to auto. And the fault's removed. Yeah. So with enum alarms, change of state enum alarms, very similar to Boolean, but instead of having a single alarm state, you have the option to have more than one alarm state, and you've also got the option to have valid values for your fault algorithm. Okay, so if we say that all values are valid, okay, now it'll just be an alarm whenever it's on. Okay, so if we go back, we go action, set the value to, it's currently auto, we set it to off. Nothing happens. Action, set the value to on. And it's gone into alarm. Okay, it's in here as an off normal condition that we can acknowledge. Yeah. Action, set it back to auto, and we're all good. Okay. So that's alarm extensions. Okay. Next thing we look at is trend extensions. Yeah, trend extensions. So if I look at my zone temperature here, I've got a numeric interval history extension. So in Facility Explorer, trends are referred to as histories. Okay, so trend is a Metasys or Johnson Controls term. In Facility Explorer, it's referred to as a history. Okay, and I've got a numeric interval history that's going to record every 1 second, so very fast. And it's going to store 500 samples at 1 second intervals. And if I'm on my interval here, I can right click and view a history chart, and there's my 500 samples. Okay, I can view it as a chart, or I can view it as a table of values. Okay. So that's my numeric interval history extension. So how did I get that? So if I go back to here, go to my zone 1 temperature, and I'll get rid of that. So this is my zone 1 temperature. It's sitting here on the tree underneath custom control. And currently it's got an out of range alarm extension, but that's it. If I want to add a history extension to that, I can go to my control palettes, my kit control palette. And do I have? No, I don't have it in there. Sorry, I need to go to my history palette. And I can see extensions. And I've got numeric interval and numeric change of value. So if I put numeric interval, I grab it and I drop it on there. Numeric interval. It's currently disabled. So I will enable it. I'll just finish setting it up first. The history name is going to be parent.name. So it's going to be zone 1 temperature. Okay. So if I could just give it any old name, say, let's call it sample history. Okay. And my interval will make it 30 seconds. So 30 seconds. And I will enable it and save it. Okay. Then I can look in my history config. My record count will be 500 records. And when it's full, it's going to roll over. I could also stop collecting at 500. Because I'm on a PC, a computer, I can set my capacity to unlimited, in which case it'll just keep storing it forever on my hard disk, and eventually my hard disk would fill up and I'd have a problem. But until then, it will happily keep on recording it forever. Okay. In an FX80, you don't have unlimited storage, so you should always instead have a record count and then a number of samples that are going to be stored in the memory of the FX80. Okay, by default, 500 seems to be the number. And it really comes down to how many samples do you want to have available in the FX80. Now, if you have an FX80 connected to an FX server, then you can transfer that trend data from the 80 to the server. And when it gets to the server, it can be stored as unlimited. So in that arrangement, you just have to say how much backup data do I want to, backup capacity do I want to have in my FX80. So again, every one of these, every record takes up a bit of space in your memory. But in reality, you can, as long as you keep these reasonable, like 500 is a good number. If you put 10,000 records on 100 points, you're probably going to get yourself in trouble. You just have to be reasonable. So right now we've created this, it's running, it's called example history. And if we right click on the numeric history and view the history chart, we've got a couple of samples being taken. If I look at the history table, they're the samples and they've been taken at 30-second intervals. And it coordinates it with the on the minute. So it's 30 and 30 minutes, 30 seconds, 31, and then 30 seconds past. If I click here, it will start refreshing this as the samples get taken. So that's the live updates option. Okay. So there it's updated. Same for if I'm viewing it as a chart with the live updates option. It'll periodically go out and retrieve the whole trend data. Okay. So if I go and look in on my station, I've got my Facility Explorer folder, then I've got a files hierarchy, then I've got a history. And then this is the station. And under here, I've got all of the histories that I've created so far, including the one called example history. Okay, so the thing to notice here is that the history name needs to be unique. All right, so you can only have one example history. If I double click here, it'll go and retrieve that example history. And I can read it off, and it's recording the value, but it's also recording the status. So you can see that it's in alarm, and then it gets down below 23 and it's normal. Okay. I can also got my computer room. I can drag that and put it onto there. And I've got two points on the same graph. Okay, I can choose to display today or auto or time range. So I can start date and an end date. I can go today, last 24 hours. In this case, because I only have 500 samples and it's sampling pretty rapidly, there's no difference. And if I can go back to the last 7 days, again, doesn't make much sense in this example. So that's where the history gets stored under the station, and then using the name that we gave it back here in this name that we gave it here, history name. All right. Another type of history is numeric change of value. Okay, so I can put a second, I've got one history on here already. I can add another one by taking this and dropping it on there. Numeric change of value, there it is. This time I'll stick with the history name, which is parent.name, which will be ZN1 temp. And just looking over here on my histories, I don't have one called zone 1 template, so that'll work. My history configuration, I'm going to have 500 samples. So this time round I'll go unlimited. And the interval is irregular because it's on change of value. So I'm going to say every time it changes by 1 degree, I'm going to record the value. All right. So I save that and I enable it. And away you go. You notice here you've got the option to have an active period. So you could say, I don't want to record this on the weekend. I only want it Monday to Friday, starting at, say, 9 o'clock in the morning. Going through till 5 o'clock in the PM. Okay. So by choosing this active period from Monday, Monday to Friday, from 9 AM to 5 PM. Save it. Okay. Now if we go and have a look at this, here the history chart. That's what I got. I look at it as a table. So each time I saved it, it starts the trend again. But it's recording it basically every time it changes by 1 degree. I believe that what we had is our change times 1 degree. And if we look over in our history, we should have something in here called zone temperature. Zone 1 temp, double click. Oh yeah. So these breaks here for the times when I saved it and effectively started the process again. So changes by 1 degree, then I saved it, and now every time it changes by 1 degree, it records it. Oh no, it's recording it every 0.1, 1 degree. So that's the change of value for a numeric interval. Where change of value is more useful is for a Boolean point. So if we go back to here and we look at our cooling output, which is this guy here, if we wanted to put a Boolean change of value onto that, we can drag it and drop it. Doesn't like it. Okay, if we double click so that we're in the property sheet, now we can drag and drop Boolean change of value. It's going to have a name called parent.name, so it's just going to say cool. So in this case, we'll change it to parent.parent. Okay. We'll save that. We're going to have 500 samples. We're going to roll over and we're going to enable it. Okay. And that parent backslash parent, so it's resolved into a name called custom control backslash cool. And there it is there. Okay. So by having parent, I've got my custom control as my first field, followed by cool. Okay. If I right click and view my history chart, I don't see very much. My history table, it started when it was on. It's currently on. Get the Y sheet. So at the moment the set point's at 22. So let's change the set point to something a bit higher. To 23. So that it goes off. So this has gone off. If we look at our custom control history, and look at it as a history table, We can see it recording the on and the off, on, off. We go back to our chart. We can see it like that. Or if we go look at it from here, we're looking at it as a web chart. It's looking, displays it like that. Okay. So that's our history. Likewise, you could do the same thing for an enum. So if we went back to our wire sheet, we've got our enum that we did before. This guy. You can double click. He's got his change of, he's got his alarm extension. We can add a history extension for enum, change of value. Okay. Then we've got our parent dot parent. Got 500 samples. Everything else, we enable it and we save it. Okay. And then it appears in here. With just one value. If we find that point over here, and there he is. If we right click, action, set him to on. Action, set him to off. Action, set him to auto. Okay, if we go back to our there's our three states. We look at it as a history table. It's recorded each change. Okay. So you can put an interval history on an enum point or a Boolean point, but it's not a very efficient way to do it because it'll just sample the value of that point on an interval, and so if the point is turning on and off rapidly, you might not record every change of value, or if it's turning on and off very slowly, you'll be taking lots of samples when it's on, lots of samples when it's off, lots of samples when it's on, and you'll never actually record the important thing, which is when did it exactly turn on and when did it exactly turn off. So change of value makes a lot of sense for Boolean and enum points. Interval makes a lot of sense for numeric points, but numeric change of value is also sensible for things like set points, which are only change every now and again. So if you had a zone set point that might be adjusted by the operator once a week, then putting a change of value on that set point means that you only record its value whenever it changes, rather than continually reading the same value and storing it as you would if it was an interval. So there are our alarm extensions. Now, so we've put in alarms, we've put in history. The last thing is totalization. So we go. Totalization, I think, is in the kit control. Yeah, so in our kit control palette, under control palette extensions, we've got discrete totalization and numeric totalization. So if we go back to, we can work with our enum point. So this is our enum point. Just say we wanted to record how often, how much time, what's the run time for this output. Okay, so for that, we choose discrete totalization, and we drop it on there. Let's take that off there and go to just delete that. We need to find a binary points like our cooling output. Let's go there. On our cooling output, we've got a Boolean command failure. We've got a change of value history. Now we'll add a discrete totalization. Okay, so the totalization gives us a change of state count. So every time it changes state, we record that. So we can record it every time it switches to active. Okay, so the number of starts, and then the amount of time that it's in the active state. So currently it's been active for 30 seconds, 40 seconds, and the update interval is currently set to 10 seconds. So this active time will be updated every 10 seconds. Okay. So there we go. We've got our cooling output. Now, if we wanted to put that on our graphics, say, I edit my graphic. This is my cooling output here. Stick it over there. I duplicate that point there. When I look at the binding for that point, it's got cool, and underneath cool I've got my discrete totalization extension that I added, and underneath there I've got my elapsed active time. I go OK to that. OK. And OK. What's it say? It's my text. I just need to go %. Go OK. OK. And there's my runtime for my cooling. And if I go in here to my text again, and I can say runtime. Okay. Okay. So there's my runtime. If I duplicate that, and double click, but this time instead of elapsed active time, I choose change of state count. So OK. And then change my text to be starts is 4. Okay. The other day we did in our wire sheet, we had our, was it this one? We had our lead lag controller that was turning on our 3 pumps based on the cycle count. Okay. In order to do that cycle count, I set up discrete totalization on my status, and I connected to the change of state count. Okay, so for each of these, this status here, I've set up discrete totalization on each one so that I record the number of starts and also the hours run. Okay, and at the moment, which one's in control? At the moment, I'm using the lead lag runtime is controlling the output, and it's trying to equalize the hours run on these 3 outputs, these 3 pumps. Okay, and you can see that they're all about 11 hours and 51 minutes. Okay, so next time it starts, we'd expect it to start pump number 2. This guy here, we'd expect him to come on next time the input comes on, because he's got the least hours run at the moment. So he just came on, and yep, sure enough, this one is on. And his hours run is going up. Okay. So 11 hours, 51 minutes, 18 seconds, 28 seconds, and so on. So next time round, we'd expect it to start up number 1. All right. So that's an example of using the discrete totalization, which is under here, and connecting it through to our lead lag runtime controller, so that it sequences based on hours run. Okay. So that's totalization. Now all of this that's yeah, so we've come to the end of our time. So what the next subject I was going to cover was, how do we do this efficiently so that we set up, if we've got a lot of points where we need to add extensions to. So for example, we've got our backnet network and we've got our VAV controller. We've got our point extension manager here, JCI point extension manager. That lists all of our points, and it has a column for trends, alarms, and totalization. So if you wanted to trend the cooling output, you'd come here and go click on here. So cooling output, I right click, and I can choose to put a change of value history or an interval, or a 1 minute interval, 5 minutes, 30 minutes, or remove. Okay. So if I went 5 minute interval, I've just set up 5 minute interval trend on VAV01 cooling output. If I look on my trend down here, VAV01 cooling output, it's been set up and it's active. Okay. Likewise, if I wanted to set up an alarm on that, so I can tick this box, right click, and do an out of range alarm extension on that cooling output. Okay. And I can save it. Now I've got an alarm extension on there. So if I go and look at my VAV points cooling out, I've got my outer range and my 5 minute interval. Just by ticking those two boxes and saving it. Okay. Now, at the start of tomorrow's session, we'll go through exactly why there's a list here of where did that list come from, and how do I add to that list or remove from that list, and what exactly happens when I tick this box. Okay, so we've run out of time for today, but we can cover that quickly tomorrow. And then for the rest of tomorrow, we will be looking at Niagara networks. So setting up an FX server so that it can communicate to FX80s, and how we do things like transferring the history data out of the FX80 and storing it in the server? How do we deal with schedules so that you can have a common schedule in the server that gets shared to all of the FX80s? And also, how do we manage alarms? So the alarm gets raised in the FX80. How does that alarm get transferred through to the server? So we'll do all that tomorrow. But first thing tomorrow, we will have a look at how we get this. We'll just close this out, show you how to get this list, how to set this list up, and same for totalization. Okay, so any quick questions on what we've done so far today?
I'm good. Anybody else?
Okay. Okay, sounds like we're all good. Thanks for coming in today on your day off, and I'll talk to you all tomorrow. Thank you.
Right. Thanks, David. Fantastic.
Thanks, Fred.
Thank you, David.
Thanks, Edward.